Welcome to part 1 of a completely new build series. I'm using some of my experiences from the previous build, and also in this one I'm going to combine some parts of the Voron 2.4, especially the Z axis, and then I'll take the rest of the printer from the Trident. That will be the gantry. A lot of other things I will change in this build. I can't spend much on this project, so I'm absolutely not following the sourcing guide, not even close. But I recommend you do, of course. I decided to get a new power supply, and this one is brand new, and it's not a mean well, but I think this will do just fine. I wanted to use the BTT Eddy in this project, but I changed my mind and I'm going back to these basic inductive probes. As for the heated bed, my plan was to use an old and very power hungry 24 volt bed, but I'm buying a new one. It's still 24 volts and it's still cheap. This is the model the Voron design team provided for us, and it's in great detail. You can have a look at every little thing, like all the fasteners and how everything goes together. And that's really helpful when you're building a printer. And it's also very helpful when you try to remix something or change it like I'm doing. When looking at Trident design, the frame, you can see that this has been designed for an enclosed printer with panels going all around the printer, and the size of the frame makes a lot of sense when that's what you're going to do. But that's not what I'm going to do. I will build an open printer, and in that case these top extrusions, they don't seem to be necessary at all, so I can do some changes to this. I changed the frame into this. I removed all the top extrusions, added a couple extrusions in the back and one in the front. You could say I moved that one down. The lower part, or the lower extrusions, the skirt, is a lot like the 2.4, the Voron 2.4. The front part is exactly like the 2.4. I changed the sides. It's a little bit cleaner, and I don't need all the fans. Just going to be a fan on the power supply. Looking at the back of the printers, I've done some more changes. There's just one stepper motor in the back, not one in each corner as in the 2.4. That means I have 3 points to the bed, and I can use the Trident Z-tilt functionality just as it is on the Trident. I have this space for the electronics, and I'm going to do this just like I did with the previous build, with one controller down here and the other one here. That will keep the wiring simpler, and it's a much easier build in my opinion. You will then just have the Raspberry Pi down here and the USB to this electronics box and to this electronics box. Looking inside the printer, underneath you can see this is the place for electronics, and this is where I'm going to use an external MOSFET for controlling the 24 volt heatbed. So this is not the mains operated heatbed, it's 24 volts. One of the parts I had to spend some time on was this bracket for the bed that also serves as the belt clamp or belt. I haven't finished this drawing completely, but you can see how this is intended to work. I don't like the aesthetics of this part, so I may have to change that later, but this is the basic idea. And it's something similar at the back of the printer. Like you can see here, it's the same type. And you might wonder why I'm using this and not a belt clamp. Well, this is very simple and easy to replace a belt. And if this breaks, that's just fine, because I don't want this to crash into some other component and destroy it. I rather like this one to break and then to replace, just reprint this part. That's much easier. And I've been using a similar technique on my other printers, and this seems to hold up quite well actually. So that is the plan. I think some things might change, like I'm not entirely sure if this is going to be the exact location for this front extrusion. It may move up or down compared to what you see in this drawing. There's also some other details I might change. I have already changed these A and B drive parts just to cover this corner, and there are a lot of other details I probably have to change along the way, and maybe I'll make some mistakes no matter how well I try to plan this. But let's get on to the actual build. This frame is using 2020 extrusions exclusively, and I need to cut all of them because I don't have any one ready. And these are all the extrusions cut in the correct length. I promised you some mistakes, and I already made a couple of mistakes. You can see them in this image. It might be difficult, but it's there. Taking a closer look at these extrusions, we can see that they are not all V-slot. 2 of them are in fact T-slot, and that's not what I need for this build. I can use a T-slot extrusion by using an inner corner like this, but I had to replace the other extrusion with the proper one. This frame will be assembled by using the very basic technique of blind joints. You just put on a button head screw and slide in the profiles like this, and then tighten them through some access holes. But of course we have to prepare the extrusions for this. I'm getting ready to tap them with the M5 tap and some oil. I do this by hand to keep some control. It's boring, but doesn't take too long. The next step is to add the button head screws, and in this image you should have seen 7 profiles with button head screws, but there's only 6 and 1 with the inner corners. The next step is to drill some pilot holes for these access holes so you can get hold of those button head screws. And I always use jigs for this. This is the only time in this build you actually could have some use of a drill press, so we can do this by hand as well. I'm then drilling the actual access holes using the pilot holes. Then just rinse and repeat. Tapping and drilling creates a lot of chips, dust and burrs. You really need to remove all of that, otherwise it's going to be difficult to get all these pieces together properly. I'm using a cleaning spray to finish this off, and this is what it's called in Icelandic. And can you pronounce it? I'm not even going to try. With all of the preparations out of the way, we can start to assemble the frame. You should do the assembly on a perfectly flat and stable table. I haven't got that, but I'll still do this on this table, and I know I can square it up after I have finished getting all these pieces together. At some point during this build of the frame, you have to get your MGN rails ready. And these are my Z rails. These are not the standard ones, these are MGN 12H. And I'm using T-nuts for M3. I'm using 1 bolt in about every second hole, and then this should slide into the extrusion. Unless you are really careful, you should block the travel of the carriage so it doesn't fall off the rail. You can use something like this. You can then slide the MGN rails into the extrusion, and at this point it doesn't matter if it's in center or exactly the right height. You can adjust that later when you have completed the frame. I'm not tightening these fully, I just prevent them from falling out. I'm not thrilled about how this part looks, but there's some aspects of it I like. I like that I have a screw in center of the belt attachment. That will make this part stronger, but it needs some aesthetic cleanup. I also expect to do some changes to get spot on with the belt path. That's just based on the CAD for now. I like to add some cheap T-nuts, at least when I'm absolutely certain where they are going to go. And I use these stoppers I made in TPU to prevent them from sliding around inside the frame. I'm getting the MGN rails for the Y-axis ready. As you can tell, I had to cut this off with the angle grinder. I didn't have the correct length and I didn't want to buy any new rails. And these are MGN 12H, not MGN 9s like in the sourcing guide. And I do this exactly the same way as on the Z axis. It's a bit fiddly to get the clearance right on this, and I had these T-nuts a little bit too tight, so I had to loosen them before they would fit in. Then they just slide it in. And then of course you have to tighten them, and this is just preliminary. I will position them correctly and center them later in this build. Hopefully, unlike my extruder, I'm now going to skip some steps, and this is the completed frame as of now. I have cut and added a couple of extra short extrusions in the back of the printer, and those are attached with the inner corners just like the T-slot. I still have to design and print some parts that are specific for this build, like for instance this front arm. It's a mirror pair on the front left and front right. This is a two-piece design, and I use a brass insert, or rather two brass inserts, to get this to print without using supports. We also need a custom part for the rear arm, and in this one it's a brass insert in the base plate and one in the arm. Otherwise it's about the same dimensions. We need a custom bracket for the tensioner. And this bracket is my design, but this tensioner and the idler, that's the original design from the Voron 2.4. Just have to print 3 pieces of those. It's pretty easy to print these parts, and I made them in 2 different components. One reason is that I want them to print without using supports, and the other one is that I want it to be possible to change the type of arm you use with this. It could be a different bed configuration. The bed could be further away from the front of the printer, and you may need some different configuration. So I'll provide this as a step file for the arm. I used Eisenmate ASA for these black parts and ABS from Filament PM for these copper parts. You attach the arm to the base plate with M3 bolts. Initially I tried using 10mm bolts, but they were too long and rubbing against the belt, so I had to change that to 8mm later on. These parts are not symmetrical, so they will only fit on the correct side. And that's not by design, that's by chance, sort of. This is what the completed part looks like, and I think it's quite okay. We're now moving on to the tensioner, and this is the original part. The orange part is just from the Voron site. And you attach this 30mm M5 bolt inside this idler. And this just screws into plastic, so you don't need to tighten this too much. Adding the tensioner to this bracket couldn't be simpler. I'm just using a 25mm M3 bolt. And I'm also using a thumb wheel. These types of thumb wheels, we used to have them on our old printers when we did all the bed level adjustments manually. Maybe you have some in your old parts bin. We're now ready to attach these parts to the front rails, to the left and to the right, and to the rear. At this point it would be tempting to just mount the bracket for a tensioner, but you shouldn't do that. Do the front idlers first, because now you have access to them. When building these front idlers, we turn to the Voron Trident assembly guide and the AAB drive and idler. And you can see the components with the AB drives and the idlers. This is the front part of the idlers, and we will do this just as it's documented. There is absolutely no need to change anything on this part. And in fact, on the gantry, I'm not going to do much at all that deviates from this standard gantry for the Trident. That makes this a lot easier, and it's documented much better than I could do. We now have easy access to the front idlers and can move the rails as well all the way, and that makes it easy to attach the tensioner bracket. The next step is to build these set drives. The only problem is I don't have any parts, or almost any parts. I do have these D shafts, 61mm long. In my previous build these were 60mm and round. I also have these two bearings, but only two pieces. I have a lot of old parts, and among them V-wheels like these. And these should contain a bearing that is the same size as the one I want. Next step is just to get the bearing out of this V-wheel, and how difficult could that be? It was in fact quite difficult, and I damaged the bearing badly. I can't use this. I have to find something a little bit smarter than this. I'm sure there's a tool that could work for this, but I'm 3D printing, and I'm trying to 3D print a tool I can use for extracting these bearings. This is what I came up with. A very simple design with a 3D printed part, a washer and a bolt. I would then tighten it until the bearing got loose from the wheel. And it took some force. There you can hear it got loose from the wheel. I'm getting two bearings from each of these wheels. So I had to repeat this a lot of times to get everything I needed. Thankfully, 3 set drives is enough, but I still haven't got any gears. So I had to go to printables and look what I found there, and I found this is a 2-part design that I can glue together. I made some changes. I added a chamfer and modified it to fit with the shaft that I had. Had one side grind off, and I found another one, 20 teeth pulley. I did the same thing to that one. By now I have the parts I need for the build. They may be of questionable quality, but I'm going to try them out anyway. And I'm turning to the 2.4 assembly guide and will follow this just as it is. The assembly guide is very impressive. It's got a lot of detailed information you need when you do this build, and how to check that everything you built is in the correct position. This takes a lot of effort, and I'm amazed by how much time they put into this. If you follow this guide, I think it's going to be very difficult to make any serious mistakes. But of course I'm introducing some very dubious parts, so we'll see how that turns out in this build. Getting on with the build, I need a lot of heat set inserts for this build. And I'm getting these from CNC Kitchen. These are M3 by 5 by 4. That's the perfect size for this, and the holes are 4.7 millimeters. And I'm using a standard soldering iron with a special tip that matches these heatset inserts. All these parts are printed in Eisenmate ASA. And I then move on to the retainers. They also have a lot of heatset inserts. I think my soldering iron is at 260 or 270 degrees at this point. This is the drive unit with the printed gears, bearings, shims added. And it spins freely, just like it should. I could of course buy these gears in metal, but I was thinking I should trust some of the components I can print myself, and I'm going to try this out, and then we'll see. Before closing this part, I have to remember to attach these belts. They won't go in when I have completed this part. The next step is to add some 40mm bolts to attach the retainer to the rest of this drive housing. And I'm using proper gates belts on these. I had an extra set from my last build. I should have cleaned the surface on these prints, but I'm not going to bother with that now. The next step is to add these bottom plates, and I'm using a short 8mm M5 to hold this nut in place while I'm placing this on the drive unit. I will then remove this later. This plate is for attaching the feet, and I have printed some in TPU. This is printed in Fiberflex 40D. Next up is getting the steppers ready for the set, and I'm checking the height of the pulley with a special tool. It's very convenient to do it this way. With that we can move on to attaching everything to the frame. And I'm starting off with a gear unit. Just need to get these two T-nuts into the correct position. You then simply attach them with two long bolts like this. Next up is attaching the stepper motor. I just need to get this in the right position. And the stepper motor slides in. This part of the build is really enjoyable because this is a very good design. You just attach the stepper motor loosely to the extrusion. Don't tighten it fully. Then you tension the belt with the arm, and then you can secure the stepper motor to the extrusion. That's it. I'm then adding the TPU 3D printed feet, and this is the center drive mounted onto the extrusion. I'm adding a corner part with the rubber feet in each of the rear corners, so we have rubber feet in all four corners of the printer. I'm ready to attach the belts for the first time, and these slide in without any problems. And I like this way of attaching the belt. It's easy to adjust and easy to replace the belt. When doing this, I discovered that there is a problem with this piece. It rubs against one of the bolts. The belt rubs against one of the bolts, and the belt is too far away from the extrusion. I have to redesign and reprint this part. I redesigned this part by making it 2mm thinner and countersunk the one bolt that was interfering with the belt. The reprinted part worked fine, and I have the clearance for the belt and also the correct path for the belt. So that's fine. I did the same change on the other side, and that is also correct now. I have to design and print some more custom parts, like this angle bracket. The original one is too long and interferes with the tensioner brackets below it. And here it is attached to the printer. There's just enough room for the M5 bolt. Next up is the XY joiners, and this upper part is the original part. The lower part is a remix, and I will leave the link in the description. This is not my design. This is the designer's model on printables, and he's also got some other models for Trident. And he also did this just to adjust to the parts he had available, just like me. And these are the joiners completed. And this is the A side on the printer. And this is the B side. Next I have to design and print these bottom covers. It would be nice to have a printer that could print larger, but I had to do this as 4 separate parts. I'm probably not going to buy the Orange Storm Giga, but I'm working on designing a printer that will print 300 by 900 millimeters. Subscribe to keep up with that project. I'm closing in on 1000 subscribers. Thank you for your support, and I hope that will help me fund future projects. Now on to the artistic part of this build. I've gotten some help from my wife, and she helps me with adding the hardener. And this is a mix by weight, so it's 50% hardener and 100% of the resin. I'm using Glasscast 3, which is a bit different from the previous build. And this is the resin. In total we needed 450 grams, 300 grams resin, and 150 grams hardener. You obviously need both the hardener and the resin to do this. The next step is to mix the hardener and the resin, and the objective is to get rid of all these strings, or whatever we should call them, and make this a much more clear liquid. And that takes some time. You should probably use about 4 or 5 minutes on this. With that completed, we can add the metallic pigments. This is the shimmer copper, and I think this is a beautiful color. We did add more as this progressed and used a lot of these metallic pigments. This looks beautiful and very promising. By this time I took over, and I wouldn't let anyone else mess this up. I wanted to do that myself. We didn't really know if 450 grams would be enough for all of these plates or covers, but we found out that that was just about the right amount. Could have been maybe a little bit more, but 450 was fine. The resin will level itself as long as the table is level, and this time I actually did level the table, so it was much better experience than the last time I did this. The resin will eventually flow out to all of the sides, but it helps to give it a little bit of help to release the tension, and then you just have to wait. This type of resin hardens in about 24 hours. And this is what it looks like the next day, and I'm very happy with this result. Leaving the art aside and going to the technical side of this build, this is the inside of the rear skirt on the printer with the position for the MOSFET and for the caddy. I made that part a little bit smaller. And this is the front. It's pretty much stock, and I decided to keep the display as I've been using that on the Voronish 1. The rear side of this skirt is far from stock because I have a stepper motor in the middle and I have this caddy for the electronics, but it's very easy to customize this. I made some covers for the corners as well. I'm ready to attach the art to the printer, and I'm just using super glue. Until I get this very large printer, I have to do all of these components in separate parts. It's satisfying to see that this actually fits. And what should you use for a weight? Of course, a stepper motor. Same thing on the other side. finally some use for these hybrid steppers. Then just have to check that this is firm, and this looks okay. I'm really happy with the outcome of this. I like the copper color, but as was mentioned in one of the comments, black extrusions would look even better, but this is what I have. The next step is building the A and B drives, and I will follow the assembly guide, and you can see these are the A and B drives. This very simple part to assemble, and it's just some bearings and shims. You only have to keep track of what is the A and what is the B drive. You can see that with a notch on the A drive, that's not on the B drive. And this is a stepper motor attached. And I'm using these Van Tie steppers I had. I attached that to the printer, which is also very easy. Getting these T-nuts in the right position from below this extrusion takes a little bit of patience, but it's not difficult. It's just me being clumsy. And now ready for attaching the bolts. One detail to keep in mind is that on one side there's a M3 and M5, not M5 on both, as you might expect. This is what the printer looks like right now. I'm just waiting for a few parts. One of them arrived very timely today, and that was the gates belts for the X and Y. So I can start on that part now. Just after releasing that video, I got a comment that I should use these beefy front idlers. And I totally agree. These look a lot better than the original ones. That said, I haven't had any problems with this on the Voronish one. But this design compresses the plastic instead of trying to tear it apart, so I guess that's a good thing. And this is what it looks like on the printer, on the left and on the right side. I'll use these clamps when installing the belts. Unlike the Stealth burner mount, the Dragon burner mount doesn't have a separate side for each side of the belts. So doing it like this will make installation a lot easier. This is the completed belt path on the X-axis and the rear on both sides. And I think this is a very clean way of designing a belt path. And this time I didn't even have to look up the documentation to figure out the belt path. So this is good. I'll then check the distance between the X-axis and these A and B drives, and this looks about right. The part I'm going to use to attach the bed is actually the one that was designed for the rear attachment point. But I'm using this on each side just as a mirror pair, and this will be the orientation. A key component in this bed attachment are these GE5C spherical bearings. And they go inside the attach points like this, and they secure the position by 6mm M3 bolts, and you have to make sure they're not longer than 6mm. They attach to the printer like this, and they should move freely in all directions, but there shouldn't be any slack. And I'm checking that on both sides to make sure that the bearing doesn't move inside the plastic parts. I'm not following the recommended sourcing guide, so some of the parts I use are not standard. That goes for the heat bed as well. This one has 4 attachments and not 3 like in the specified version. And this is the way it's been attached to this very basic frame. Everything is fixed in place. There's nothing that needs to be adjusted on this. I'm using some aluminum spacers to keep the distance up to the heat bed. This is the bottom view, and even though I use some aluminum extrusions, this isn't that heavy. Please note that I'm not using the recommended belts either. Those might be replaced later. All in all, I am very happy with this build so far. I think it looks clean, it's going to be easy to do the wiring, and it's going to be very easy to maintain this printer, which is very important to me. I hate having to remove a lot of stuff just to replace some basic component. And on this one, that shouldn't be a problem. A nozzle scrub or brush is almost mandatory these days, and I'm going to reuse this design from the Voronish one. I bought this part from AliExpress. The other hardware will just go into my large parts bin. This is what it looks like with the nozzle brush glued on. I have attached it to the printer in the right position, and this brush actually serves as a guide when you attach the flex plate as well, so it's practical. This is how it mounts from below. It's only one M5 bolt. I'm using the Dragon Burner toolhead with Sherpa Micro in this build. This is a well-documented toolhead. It's not the same level as a Voron toolhead, but it's pretty good and it shows you all you need to know, and they have published the CAD as well. The main benefit of using this toolhead is that it is lighter and it's easier to get to stock filament due to the open design of the Sherpa Micro. There are a few things I don't like for instance there's no channel for the wires in the Bambolab adapter for the logo LED, so I just had to skip that. I didn't want to remix it just to get those channels in. I'm using NeoPixels on my build and they goes in like this, at least I guess they do. And I'm using the GDS time fans. These fans are the exact right size for this toolhead, and you just have to move away some of the cables and they will then slide in. On the left hand side fan you have to change the routing of this wire so that it will match with a channel inside the toolhead. It will then just slide in like this, and you will get a clean installation with a cable within this channel. I'm going to use a Bambolab Hotend 0.6mm with a hardened steel nozzle. And this is what you get when you order one of those. Some heat paste, a heat break with the nozzle and the clamp and the silicone sock. What's missing from this is the heater cartridge and the thermistor. I bought a 3-pack of those heaters and thermistors for my last build. And this is very inexpensive stuff. Attaching this is pretty simple, and that's due to the fact that the nozzle is already attached to the heat break. You just have to add some heat paste and then put on the cartridge, heater cartridge and the thermistor and clamp those on, and that's it. Some cleanup required and then this should be good to go. In my opinion, this adapter still needs a little bit more work. I couldn't get it to work with the M3 nuts and 20mm bolts, and the 25mm bolts, they were too long. So I had to attach some heat set inserts into these. I did remix the adapter for the self burner, maybe I will do this for this one as well. This is the Bambolab adapter with the heat set inserts added, and you can tell it's not designed for this. I had to remove some of the plastics that was pushed in by the heatset inserts, and I did that by using a bolt like this. And then the plastic fell out. With the heatset inserts added and cleaned out, I could then turn back to using my 20mm bolts, and that worked like a charm. Before sliding in the adapter, I had to close off this LED logo light with a dummy carrier. With that done, I could slide in the adapter. On top of this, you'll use an adapter for the extruder you're going to have on this build, and in my case it's the Sherpa Micro that attaches with two bolts like this, two different lengths. And with that, this tool head is ready for wiring. I'm going to use an external Raspberry Pi in this build with a simple case, and it's going to use a 40mm fan. And I use this Raspberry Pi 3B, it's the right compromise in my opinion, with power usage, noise and cooling requirements. I'm using a proper SD card in this build. I've used variations of this case in many builds, I do like it. It's very simple and it fits nicely to the 3B Plus. In my opinion, this is the simplest way to get the software onto your Pi. You just select the type of hardware, you select the operating system, and this case a specific operating system for 3D printing. And listed under 3D printing you will find Mainsail OS. And you just select this. Then of course you have to choose the storage. I'm using my SD card, and I also do some customizations like setting a different host name, password and stuff like that. We'll then apply these settings and start to write to the SD card. That takes a while. Hopefully you will see then this message and can pop the card into the Raspberry Pi. I chose to add a 40mm fan to this case. That should be more than enough cooling. Now we'll get the power for this fan from the main power supply in the printer. I don't have any 5V fans at this time. I have everything else but not 5V. We're then going to connect the Pi to power and Ethernet. And it starts up like I expected. There's nothing connected to this via USB, but we can get into the machine settings and have a look at the update manager. And you can see that there's a lot of updates missing on this, and I'll just start by adding all of them. This could take several minutes with that many updates. Eventually it will complete, and you might get this warning, but then just press try again. And you can close this. With that, everything is updated. There is, however, one message in here. You can see this information message. And this is not a warning or an error, it's just information. With that done, I'm going to connect to my other printer, the Voronish one, and I'm going to steal some of the configuration files from this printer to save some time. I'll simply download the files I need. I will then upload them to the Voronish 2. With all that done, I'm getting ready to start on the wiring. In my last video I mentioned that I would consider remixing this adapter, and that's what I did. I added a wire channel for the LED logo and made room for some heatset inserts. These will have to go a bit below the surface, but that's not a problem with the right tip. I also had to change the cowl to fit the sensor position. The sensor position on the previous one was too close. And this is the way the LEDs should fit. I showed that incorrectly in the previous video. This is what the tool head looks like after all the changes and the new sensor position. I also changed the Pi mount to get better clearance for the USB power cable. During the first tests of movement, I discovered that I didn't have enough vertical travel on the Z-axis and had to change the bed arms. I moved the front extrusion a bit down to get better access to the build plate. So quite a few changes. Just like in the Voronish 1 build, I'm going to use D-sub-9s to connect between the tool head and the controller card. And I think this is a pretty clean, no canvas or multiplexing needed. But I have to check that these cables are okay. I'm checking for continuity and shorts in these cables. I've attached the power supply with a couple of brackets, leaving some room for the airflow. And this is the connections and the MOSFET controller card. This isn't exactly mil-spec wiring, but it will have to do. To hook up the display, you just need these two flat cables to the controller card. It's time to switch on the power for the first time. I'm always looking for smoke from somewhere, but it's okay. I'm pretty confident that this is correct, but you never know. Yeah, that's good. The lack of smoke doesn't really tell you that everything is working, and I had this issue. The MCU shuts down because of temperatures outside of the defined range. That's expected behavior from the SKR Pico. I then connected a dummy thermistor to just get this MCU running. With that in place, everything was normal. And you can see I have some temperatures. They are not correct, but I have a reading. Looking at the machine and the MCUs, you can see the two controller cards, the SKR 1.3 and the SKR Pico. I'm using an inductive probe for the Z stop, and the way I test this is by using a metal object close to it and then check the status. And please remember that this doesn't happen in real time. You have to refresh or reload. Moving on to checking the motion, and this was a fail because this moved in the incorrect direction. That's an easy fix with just inserting an invert sign in the configuration file. After that was changed, the motion was correct, and this is what you should see when you do the stepper bus. And I'll check this both on the left and on the right side, and of course on the rear as well, but you can't see that in these images. Yeah, that's good. I'm now testing out the nozzle scrub macro. This should move the printhead to where the scrubber is and then do this motion. It will then home again. The silicone brush isn't mounted at this point in time. I'm getting ready for the first print, but that wasn't without fight. My build plate got some really bad battle scars. The nozzle dug in and made a lot of damage. And it's hardened steel, so that didn't make it better. I'm now running the Z-tilt function, checking each front corner and then in the center back. The position of the inductive probe isn't ideal on this printer, it's a bit too far from the nozzle. It works, but I will probably change this quite soon. The printer is now starting on a bed mesh. I think these probe points could be spread a little bit more. The readings I get from this inductive probe are pretty consistent. Probably will change with the higher temperature though. With the Z tilt and bed mesh completed, we can start the print. That starts with the homing and then the prime line. I'm printing the Voron cube as the first print. And this is the actual first print. No tests before this one, just check that it could extrude plastics. And I'm printing in black PLA. Cheap stuff. The Z drives with the printed gears are busy doing all the Z hops. I'm printing this in a 0.24 layer height and with a 0.6 nozzle. The beefy idlers are working hard. Not sure about the belt tension, looks a little bit loose. This is the A drive at work, using those Van Tye stepper motors. The print is getting close to finishing. And I used all the default settings for the 0.24 layer height in Orca Slicer. And that's the Trident 300 settings. The print isn't too bad. It's still some things I have to do with this, but it's absolutely not the worst first print I've ever seen. I think there's hope for this one. Thank you for watching and goodbye.